All right, so this is for the 240 Allegheny um, campus, and I'm going to start off with the question 11. I think there's two reasons question 11 gets missed, and please let me know in the comments or unmute or whatever if this is the if this is a different numbers. But I think what's wrong with this question is you're doing it right. It's just that the key is wrong. Because I think the key says, I just want to go to it real quick. The key says, oh, maybe I don't have the key. Probably because I changed the questions.
The key says 22, but it should be 0.22.
Okay, thank you. All right, so let's take a look at that. So thank you. Yeah, so I'm pretty sure the key was wrong. I just couldn't remember what was wrong with the key. I actually thought it was like I had 13.1 like in my head, but I could be thinking of another question. So let's look at this question here. This is one of your it's supposed to be like a complicated multi-step type problem because it's asking you to convert micrograms to milligrams and pounds to kilograms, although you don't have to worry about that. And then eventually just trying to get to an infusion rate. So we have to convert minutes to hours. There's a bunch of stuff we have to do in this question. So let's just take a look at this one because it can be um, something there. Okay, that's yeah, someone said that they got for this one like 13.1, and that's what I got as well. So let's just work through it.
Is that for
Uh,
milliliters per hour or is it for per minute?
oh, good question. So what should our infusion rate always be measured in?
Per hour, but
Yeah.
the confusion came when it said infusion to begin at 5 micrograms per kilogram per minute.
hmm Yeah, so what they're telling you is they're giving you like it's basically it's a drip rate, right? But when we're actually doing a drip rate, the only time we would use per minute is drops per minute. And this question, so first of all, on your test, because you're at Allegheny campus, it would say at what rate should the nurse begin the infusion in milliliters per hour. So it will tell you to do milliliters per hour, just so you know, like you'll be told what it is. In the event that you're not told what it is, it's milliliters per hour. Even when you do a heparin drip, it's milliliters per hour. Even when it's like 10 milliliters per hour, it's still dripping out pretty slow. The only time we use per minute is if we have a drop factor listed. Does that make sense?
Yes.
Okay, good. All right. So for setting this up, and I see a number of you got the same answer I got, which is the 13.1 milliliters. Um, it's just this question just stinks, right? So we have to take our patient's weight, which is 70 kilograms. Then we have to multiply it by the 5 micrograms and then kilograms per minute. Now, we're eventually trying to figure out milliliters, which is fine. Milliliters is okay where it is. But in order to get to milliliters, I need milligrams. And then I don't want minutes. I need to convert that to hours. So there's a couple of conversions we're going to do. I'm just going to do a straight shot conversion, just because I'm seeing that a number of you are already getting this right. So if my minutes are down here, I want to get rid of minutes and then have my hours down here. So that's 60 minutes and 1 hour. I think you already know those things. So before I move forward, I just want to kind of check where we are. We've gotten rid of kilograms. We've gotten rid of minutes. We have hours, which is good. We want to leave that alone. So we don't have to do anything else with the hours. Just kind of let it hang out there until we finish the rest of the conversions. We have micrograms here, but I need to get that to milligrams. So what I'm going to do is I'm going to convert micrograms. So I want to get rid of micrograms for milligrams. And you remember that 1 milligram is 1,000 micrograms. So we get rid of that. And then now I can get rid of milligrams for milliliters. So that's what this is up here, right? So I put the 400 with the milligrams, the 250 with the ml. And then before I do any calculation, before I do any math, now I can see that I'm left with ml per hour, which is what I'm looking for. And if you did this and you had ml per minute, your answer should be correct. I think if you took that 0.22 and multiplied by 60, let me just see. Yeah, you'd get the 13. It actually comes out to 13.2, but you rounded up the answer there, which is fine. So, but when we do this, right? And if you're sitting there going like, why did he write it like this? I hate when he does things like this. I'm just trying to streamline this because this helps also, even though there's all this times and multiplying, um, it just you can see everything right there and you can kind of see all the steps and it's helpful, even if you're kind of chunking it out on your calculator. So I take 70 times 5 times 60 times 250. So I just multiply everything across the top. Then I divide. So I hit equals, I hit divide by 1,000 equals and divide by 400. And then I get an answer that's incorrect on from my what I recall. I think they even write 13.125. I may have written that because I'm the one who came up with this a long time ago. So I'll take credit for it. Sorry. But it should be rounded to the nearest tenth. So it should be 13.1 mil per hour. Um, so I did include like an extra question like this. So we can come back to it if we need to, but I'll I'll kind of jump to the newer stuff and then maybe revisit the heparin protocol, although I'm hoping that you guys are pretty good with that. And then some of you already came in, you saw I was working through the heparin protocol with the 220, 230 students. So that's, there's always overlap with that question. So let me just go down to some of these other questions. Oh, so this is another question that even for you guys, your fourth semester, you know all this stuff. This furosemide question gets missed a lot, and it's because there's a lot of extra information. So let me just go through it real quick. So it says your patient has congestive heart failure, ordered furosemide 200 milligrams IV daily. The available dose is furosemide 100 milligrams IV. All that's fine and good, but what I really want to pay attention to is what the label says. The label reads furosemide 30 milligrams per milliliter. So that's the piece of information that's important in addition to what was ordered, right? So what was ordered was 200 milligrams. So we don't need to worry about the 100 milligrams. That's just like the total quantity in the vial, and then it's with the liquid added, or with the liquid component of it, it comes out to 30 milligrams per milliliter. So when you're solving this, doing ordered over available, 200 milligrams over 30 milligrams times the 1 ml, and I think someone put that in there. I think it's 6.7 mil. Some of these, like I said, um, had some incorrect answers. So I just wanted to make sure in case there's something that's different or incorrect that we have those numbers there. But I think that's what you guys have too. So again, stop me if there's something I'm talking about and you need me to take a step back. I'm just trying to highlight some of the major ones that tend to trip up you guys as you're rolling into your last semester. Congratulations, by the way. All right. Um, let's see here. These are usually pretty good. This is usually a good thing to kind of review this is where we're going to do where we care about leaving it in minutes, right? So the drops per minute is what we're looking for. So like I said, for you guys, it should actually indicate what units you're looking for. So you shouldn't be guessing at it. I'm just giving you that as a heads up. Okay, I'll go back to 19. Thank you for asking. Um, so what do we have here? We have 180 milliliter unit of packed red blood cells to be given in 1 hour, and then there's a drop factor of 10. So in order to calculate my drop rate, I need I need two pieces of information. I need flow rate, which can be in ml per hour, or it could be ml per minute. Also, I need a drop factor, which is usually going to be given to us, which is our drop per milliliter. So I'm going to take my 180 milliliters, and it says over 1 hour, but I think we're at the point now where we can just go ahead and say, and we know that 1 hour is the same thing as 60 minutes, and then times your drop factor. You don't have to do what I'm doing, but I always like to kind of show you that we are putting everything in the right order and everything's set up appropriately before we even answer it. 180 over 60 is 3 times 10 would be 30 drops per minute. As a reminder, when you are doing this, if you ever get something like, let's say it's like 31.33, 3 just keeps going, drops per minute, we can't give somebody a partial drop. So we have to either round up if it's 5 or greater. If it's 4 or fewer, then we just leave it as 31 drops per minute. In this is just a hypothetical example. This is the answer to this question. All right. So question 19. Okay, yeah, so this is just another flow rate question. Oh, this is good. This is one of the reasons, and I'm sorry if I skipped this because this is usually one of the ones that I end up going over because there's extra information here that you don't need to solve. What do I mean by that? Well, let's go through the question. It says you have an IV of 500 milliliters dextrose, 5% water to infuse at 120 milliliters per hour with a drop factor of the tubing is the drop factor of the tubing is 15. What is the drop rate in drops per minute? So as I mentioned before, we need two pieces of information. We need flow rate and we need drop rate. You'll notice that this is the flow rate. So I do not need to worry about how much IV there is. I just need to know what the rate is. The only reason I would need to know the 500 mLs is if it didn't give me the rate, and let's say it said 500 milliliters over 4 hours, then I would need to know, and then I would have to take 500 over 4 to get my flow rate. But it already gives me the flow rate. So this is 120 ml over 60 minutes times the drop factor. Again, you don't have to do this, but I do it because why not? It shows us what we're left. 120 over 60 is 2 times 15. So being consistent with my other answer, it's 30 drops per minute again. You're welcome. All right. Remember when you're doing your sliding scale insulin, pay attention to what is the patient's blood glucose level, and then just make sure you're following across. So like in this, if it's 262, you look in the range that includes 262, and then you're going to give them 4 units. So you might have 2 questions like that, but there's no math involved. It's just how many units. Okay. Remember, like if it asks you to mark your syringe, mark your syringe. If it asks you and if it gives you this question with the regular insulin syringe, just remember insulin's always going to be in measured in units. So we always want to use the syringe that has units associated with it. All right. So the question I got asked for the next question was question 25. So question 25 and the questions that are similar to it, like 25, 26, basically what this question is asking you to do is essentially what the Heparin protocol asks you to do. It's asking you to convert units per hour and convert it to milliliters per hour. And it's going to give you it's going to give you an IV that you want to use essentially as your available. So in this situation, we have 25,000 units of heparin in a 1 liter bag of dextrose 5% water. So all of this that I'm kind of creating like a little bit of a box around, starting over here at 25,000, it's all in the same bag, meaning it looks like this: 25,000 units in 1 liter. Okay. So that's all together. You want to keep that together. And you know that 1 liter is the same thing as 1,000 milliliters. That'll come in handy in just a minute. So the way I set these types of questions up is very similar to how your heparin protocol works. I take the 750 units per hour, and then I'm going to convert units per hour to milliliters per hour. So what do I want? I want milliliters, and I don't want units. So I'm trying to get rid of units. So I'm going to look at my IV, what I have available. So I'm going to put the 25,000 with the units, and then I'm going to put the 1,000 with the milliliters. Okay. Remember, 1 liter and 1,000 milliliters is the same thing. I hope I'm not overestimating, like, or that there's not a knowledge gap there. I think you know that. Okay. Just like 60 minutes is an hour. Okay. All right. So I'm left with milliliters per hour, which is exactly what I'm looking for. So I'm going to take my calculator, and I'm going to take 750 times 1,000. And then I'm going to divide by 25,000. And then for whatever reason, we keep getting that number 30 again. So you're on your test, your answers won't all be 30, okay? At least I don't think they will be. Maybe they'll all be 25, but they won't all be 30. And you would do the same thing with this here, right? So this is just showing you have 1,250 units per hour, and then you're available as the 500 milliliters with the 25,000 units, and then you would just calculate the ml per hour. You would do the same thing for 27, except instead of heparin, now it's insulin, but it's still units per hour, and then it's asking you to convert it to milliliters per hour. Let's do the insulin one real quick, just because I already did a heparin one. So the way I would break this down is I'd start off with looking at the where it tells us the units per hour. Again, if you're doing this a different way, but you're getting the same answer, it's fine. Okay, so don't think you have to do it my way. So I have 15 units per hour, and then my IV is the 500 milliliter and the 100 units of insulin, and we want to know how many milliliters per hour. So I always like to start with the units per hour first, then convert units per hour to milliliters per hour. So what do I want? I want milliliters. What am I trying to get rid of? Units. Then I just use the numbers here. So 500 goes with ml, 100 goes with units, and then I can solve from there. So 15 times 500 divided by 100 will give me 75 mil per hour. I've also had students like tell me that they were taught like to kind of do like start with the end in mind. So if you instinctively want to do like 500 milliliters over the 100 units, then the 15 units per hour, we're doing the same thing. We're writing it opposite. So it still gets you to the same place. So gets you to the 75 mil per hour. It doesn't matter what you do there. What's important is that you keep these two things together. Also, if you're somebody who likes to do dimensional or desired over available, you can do that with this. The way I would suggest doing it is taking your 15 units per hour, dividing by the 100 units, and multiplying by the 500 ml. So you can do it all of these get us to the same 75 mil per hour answer. I'm just saying, like, if you really are stuck on doing this, then you can do it this way. I don't like the way this looks, even though when I plug it into the calculator, this is exactly how I envision it. But when I'm teaching it, I try and show you the dimensional analysis. That way it's not, or that way it's, for me, it's just a little bit more like we can see it, like we're writing on the board and we can actually see and eliminate and things like, even if you're not somebody who likes to do dimensional analysis. When you see questions like this, keep in mind that you want to pay attention to the label. I'm going to zoom in on this label because this actually, believe it or not, like gets missed. And it's not for the reason that you would hope for, but notice that the order's in milligrams. And then when we look at this, we have a microgram at 2 milliliters, and milligrams at 2 milliliters, and we have a micrograms and milligrams at 1 milliliter. Okay. So whichever one you use, I would just be consistent. And if it's in milligrams, use the milligrams. So like for me, I'm going to use the 0.25 milligrams per ml. And so when I'm solving for this, I'm going to take that 0.125 milligrams over the 0.25 milligrams. And then I want to make sure I indicate that it's times 1 ml, right? Per ml is the same thing as times 1 ml. If you're going to use the 0.5 milligrams, just make sure you multiply by 2 ml. Don't do 0.25 milligrams and 2 ml. That's I've only really seen 110 students make that mistake. But if you've made that mistake in the past, just make sure you don't do that. Marking your syringe, that's not a big deal. Um, this shouldn't be a big deal. You're just going to calculate the time, and then in this instance, they want you to use military time. So, like for this, if they tell you that it's infusing at 125 mil per hour and you have 500 milliliters, the way I always set this up is I take my 500 mil and I get rid of milliliters, convert it to hours. So it's 125 and 1. You can do this any other way. As long as you know to divide by 125, you'll be fine. And so you'll get 4 hours. So if you started at 0730, right? Then 4 hours from that would be 11:30, right? Or 11:30 a.m. All right. And then for the infusion rate, you can see where I kind of tweaked this up a little bit. I'm going to do what I did for my for the other for the 220 230 class. I basically said, like, when I initially like found this protocol, what you should know is like, if and I know you already know because you've done this with me before, but this whole thing is just the reference, right? This is what you're referencing to tell you what to do. And you don't need to worry about all the other things because we're just worrying about the math component. Okay. So in this instance, we have a 198-pound individual. 198 pounds divided by 2.2 gives me 90 kg. And so all we're going to do is calculate our bolus and calculate our IV rate or our heparin drip. So I know you've probably already gone through this, but the way you would set this up is you would take your 90 kgs, you're bolusing it with the 80 units per kilogram, and then we don't want units, we want milliliters. So what I'm going to do is I'm going to look at my bolus dose strength, which is the 1,000 units per milliliter. And I'm going through this a little bit quick because I kind of went over this already. If you came in at the end of the other, because I was running a little bit behind. Oops, I did this wrong. So look at this. This is actually a good kind of mistake. So I cannot cancel out units here, right? So if we're following units when we're doing this, if I were to multiply units times units, I would have units squared, and nobody wants to deal with that. So just in case you ever write things backwards like I just did, just know that that's also one of the reasons why I have or recommend that you do so, because it helps you to see before that you made a mistake um, before you do your calculation. So 1,000 units. And I think this comes out to 7.2 mil, if I'm not mistaken. Let me just double check. So 90 times 80 divided by 1,000. Yeah, 7.2. Thank you. And then for the infusion rate, right, we're going to take our 90 kg times, now we're going to use the 18 units per kilogram per hour. So 18 units kilogram hour. And then my available, right? So I'm coming up here just as a reminder. Hopefully you know this already. This is our available for our infusion rate, the 25,000 units and the 250 ml. So I'm trying to get rid of units and convert that to ml. So 25,000 units, 250 ml. Units are canceled, kilograms are gone. And before I do anything, I'm in the units that I want to be because it says how many milliliters per hour. So 90 times 18 divided by 100, and I get 16.2 ml per hour. Uh, 16.2 ml per hour. All right. So like I mentioned before, I did go through like the scenario here. So if you were paying attention before, instead of 80 units, it's 40 units per kilogram for the this bolus, and then instead of 18 units per kilogram per hour, it's 20 units per kilogram per hour for this one. So I think hopefully you're okay with all that. Um, but I wanted to ask, like, if you have any specific questions from your review packet or any other types of questions you wanted to see, let me know. I tried to highlight the ones that you did too. Okay. Yes, you got
They
it.
so they usually ask questions A and B.
Right. Yeah. You'll just get I don't think you're going to get asked the C1, C2. I just put those there as extra questions, but you will get them for, you'll get question A and B. So you'll have two questions to answer for the heparin protocol, but it only counts as one question. So whether you miss one or two, you only missed one, but you'll get it right.
Okay, thank you.
You're welcome. Good question. Okay, so someone asked me to do the labeling here, so I'm going to do that. Okay, maybe not. All right. So the couple things. So first of all, I don't know that they're going to ask you to do this anymore. They might just ask you to circle the total or mark the total, but I'll show you how to do this. So remember, you're always going to draw regular first. So the thing I always liked to do and have always coached students to do is just write out what you're doing. So 22 units regular first. So that's your first draw. Okay. And then the correct total medication. Okay. So it does say to do two arrows, and I'll show you how to do this. But all you're going to do is you're going to add 22 plus 36. So you get a total of 58 units as the total. So we definitely want a mark on the syringe at 58. Trying to get this to be straight. I think I can do better. So I'm going to mark the syringe at 58. Jeez. Okay, sorry. Anyways, we're going to mark it at 58. The other place I'm going to make my mark, and this is where sometimes it gets a little bit controversial, but I'll show you how to answer this correctly. I'm actually going to make a second mark at the 36 mark, and I'll show you why that is in just a second. Remember how we drew up the regular insulin first? So because I drew up the regular insulin first, your regular insulin is in this area. So regular is in this 22 units section right here. It's not really, but that's how the textbooks illustrate that. And then your NPH is basically all through here. This is your NPH 36 units in this area. So I know it just says to do 2 arrows. I've told students just to, I don't think you're wrong to add in the additional marks if they actually ask this question. I don't think they're going to ask this question. I think they're going to ask you just to mark the syringe. And they probably just want you to mark it at, oh, I apologize. I did this at the wrong number. This should be at 58. So, okay. So, and then the 22 units still fits into this category here. So I just want you to see kind of where that is. That's the 2 arrows that they're talking about when they're asking you to mark the syringe. Good question. Let me clean that up a little bit so you're not wondering what that is. Yep, you're welcome. Now, like I said, for the most part, your review is really, really good. You're going to have a lot more text on this test and fewer images on this test, just to give you a heads up what to expect when you are taking this test. So just be prepared for that. All right. Any other questions? What? 29? Oh, okay. Yeah, so 29, you're just going to mark the syringe. So keep in mind, so these little M's are not milliliters. Okay. This whole syringe is 1 milliliter. So you'll notice that it's not listed there, but that's what it's telling you, that this is a 1 ml tuberculin syringe. So this whole thing is 1 milliliter. So if it asked you to make a mark at 0.5, this is the area where they're asking you to make that mark. You could technically do 0.55. You can do 0.5, 0.551, 0.552. You can do that so much. So yeah. Number 11, absolutely. Oh, the extra one, sure. So the only thing that's going to change as far as the format is just the numbers are different, right? So we have 25, 50, 500, and 125, but I'm still going to do it the same way. Okay. So for me, and this is just because I can see where it's going, which is why, like I said, the big thing is, as long as you get the right answer, you're doing it right, even if you don't do it the same exact way that I'm doing it. You don't have to do it my way. Okay. If you ask my wife, I do everything wrong. Okay. So 50 kilograms times the 25 micrograms, oops, per kilogram per minute. So kilograms is gone. Then I'm going to convert minutes to hours. So minutes is gone. Then I'm going to convert micrograms to milligrams. So 1 milligram, 1,000 micrograms. So micrograms gone. And then I'm going to convert milligrams to milliliters. So 500 milligrams, 125 ml. Some of you might prefer to convert milligrams to micrograms. It's perfectly fine. As long as you get the same end answer, you're doing it right. I just want to make sure we're all on the same page with that. So before I do any math, right? mLs per hour. What am I looking for? I know it says at what rate should the nurse begin the infusion, but we discussed this earlier, right? We said that's ml per hour. So make sure that we're in the right units, and then we just plug it into our calculator. 25, nope, 50 times 25 times 60 times 125 divided by 1,000 divided by 500. And then I get 18.75. So 18.75 milliliters per hour. And then we're going to make sure we pay attention, and we're going to round that to 18.8 milliliters per hour. Oh, see, Amber, that was a secret for only that class. So I'm just kidding. Yes, I'll show you the shortcut. Um, so for those of you who weren't or didn't see what Amber is referencing, for the heparin protocol. So I'm going to go back to this. As long as you're using the standard weight-based protocol, your availables are always going to be the same, meaning you're always going to start with 80 units per kilogram uh, body weight, 18 units per kilogram per hour. Your available is going to be the same, the 25,000 units, 250 ml, half normal saline, and the bolus dose of 1,000 units per milliliter. Are there variations of that? Can that change? Absolutely. I know at Boyce they have they'll use different kind of availables, but their questions are also set up a little bit differently. So the main reason I go over the shorthand way is because if you practice this, and this is what I recommend, take your weight, take your friend's weight, take your parents' weight, take, the weight of your significant other, random weight, put it in there, and then what do you get? Now, if you're going to use a number that doesn't give you an even kg, then you want to make sure that you save your rounding to the very end. So the example I gave is, so let's say for a 198-pound person. So if I'm doing this in my calculator, I would take 198 divided by 2.2. So now I've converted pounds to kilograms. Then I would multiply by the 80 units, or the 80 units per kilogram. So I don't want to write any numbers just yet. So I'm going to multiply by 80. And then I'm going to divide by 1,000. And that'll give me my bolus, okay? Or at least for the initial bolus. So what did I actually do there? I took 198 pounds times my 1 pound, I'm sorry, 1 kg. I don't know what happened there. Let's see if I can undo. There we go. I don't know why that disappeared on me. All right. So I'm going to take my 198 pounds times my 1 kilogram per 2.2 pounds times the 80 units per kilogram times the 1 ml per 1,000 units. I don't know why that's disappearing, guys. I apologize. It's like disappearing ink here for some reason. And then that's where we get our bolus. So again, the shorthand way is just take whatever the patient's weight is in pounds, divide by 2.2, multiply by 80, divide that by 1,000. And that'll give you the bolus every time. For the for the infusion rate, you're going to do basically the same thing. You're going to take I'm going to see if I can erase this. Yes. I'm going to take the 198 pounds, divide by 2.2 times 18, and then divide by 100. Because 25 or 250 ml over 25,000, which is coming from this right here, is 1 over 100. Okay. So again, 198 pounds divided by 2.2 pounds. That's how I convert pounds to kilograms. multiply by the 18 units per kilogram per hour, and then I multiply by 250 ml over the 25,000 units, which is the same thing as dividing by 100, and that will give me my heparin drip rate. So that's the shorthand way. And hopefully that made sense, Amber. You're welcome. All right. Any other questions? If you do happen to come across or you going through the practice and you run into some additional questions, please feel free to email me. Please give me some time to reply back. But if you have a question, email me and I will get back to you um, and then and then let you know. And if you do a different variation of a question and you want to just check your work, just send me over what you did, either as a screenshot or just type it into the email, and then I'll look it over and let you know, yeah, you're good, or oh, this is where you made a mistake. So if I don't hear from you, good luck on your test. You're going to do great. And you're almost done. So then all you have to worry about is, graduation and boards and all that kind of stuff. All right. Yep. You're welcome. Thanks for coming. Oh, and as a reminder, in case I forgot to say, I will not be doing a review tomorrow. Unfortunately, I had a meeting pop up, and so I will not be available tomorrow. But if you do have any other questions, like I said, I can answer them via email. I think you'll be fine. So thanks for coming.